perpendicular lines. Two lines, neither of which is vertical, are perpendicular if and only if their slopes have a product of -1. Let's take a look at some examples that make use of these terms. Here we're asked to find the equation of the line satisfying the given conditions, giving it in slope-intercept form if possible. The first example is a line that goes through the point -1, 4 and is parallel to the line x plus 3y equals 5. Now in order to start this, what we should do is take our line that we know is parallel, the x plus 3y equals 5, and find the slope of that line. So taking this equation and setting it in slope-intercept form and solving it for y, first we'll subtract x from both sides and we get 3y equals 5 minus x. And now we'll divide both sides of the equation by 3, and that gives us that y equals 5/3 minus x over 3. Now, from this equation, we can read that the slope of this line is the coefficient of the x, which is -1/3. So we know the slope of our parallel line is -1/3, which means the slope of the line we're looking for will be the same. It will also be -1/3. Now, using the point slope form of the line, we'll set up y minus y1 equals the slope times x minus x1. And we know that the slope we're looking for is the same as the -1/3 we just found. And now, using the x sub 1 value of -1, we get x minus a -1, which becomes x plus 1, and we get y minus 4, and that gives us the equation line in point slope form, but we were asked to give it in slope-intercept form. So now, keeping the y minus 4 the same and distributing the -1/3 on the other side, we get -1/3 x minus 1/3, and then the last thing we need to do is add 4 to both sides. So we get y equals -1/3 x, and then we have -1/3 plus 4, which is really the same as plus 12/3. So -1/3 plus 12/3 is positive 11/3. So the equation of the line that we're looking for is given by y equals -1/3 x plus 11/3. Let's take a look at this next example. Here we're asked to find the equation of the line that goes through the origin and is perpendicular to the line 2x plus y equals -6. We'll start this the same way. We'll take the line that we're given as perpendicular and try to find the slope of that line so we can use that result to find the slope of the line we're interested in. Here we're given 2x plus y equals 6 as the perpendicular line. So solving this for y, in other words subtracting 2x from both sides, we get that the equation of this line is y equals 6 minus 2x. Now since the slope here is given by the coefficient of the x, the slope is -2, the slope that we want, or the slope of the perpendicular line, is going to be given by, the slope of the perpendicular is going to be given by the negative reciprocal, which in this case the negative reciprocal of -2 would be -1 over -2, which turns out to be just positive 1/2. So we know the slope of the line that we want is positive 1/2. Now again, going back to the slope-intercept form, y minus y1 equals the slope times x minus x1. We know the slope of the line we want is given by 1/2. We know that a point on our line is given by the origin, and the origin is the value 0, 0, so x1 would be 0 and y1 would be 0. And then to solve this for y, we really just need to rewrite it, since y minus 0 is y, and distributing the 1/2, we get 1/2 x, and 1/2 times 0 is 0, so we're left with the equation y equals 1/2 x. We're now ready to take a look at how to use a scatter diagram. Equations of lines can be very helpful in analyzing data given by scatter diagrams, so let's take a look at this next example. Here we're asked, or we're told, that estimates in Medicare costs given in billions of dollars are shown below. X is the year and Y is the cost during that year. So in 2000, the cost was 236, and remember this is in billions of dollars, so that's $236 billion. 2001, $249 billion. 2002, $264 billion. 2003, $281 billion. 2004, $299 billion, and 2005, $318 billion. We're asked two questions about this data. The first, make a scatter diagram of the data. Let x equals 0 correspond to 2000, x equals 1 correspond to 2001, and so on. What type of function might model this data? So here, what we have is a scatter diagram And I've already plotted the points that were given by our chart. You can see that since the points seem to rise at a constant slope, we would anticipate that a linear function would be used in modeling this data. So if we're going to try to find that linear function, what we need to do is choose a couple of points and write the equation. So I'm going to choose the points 0, 236 and 4, 299, and we'll find the slope between these 2 points. So finding the slope between these two, the change in y would be the second y value, 299, minus the first y value, 236, over the second x value, which is 4, minus the first x value, which is 0. Now, working this out, what we find is that the slope is equal to 15.75. So now we anticipate that the slope of our line will be given by 15.75. We were also given the point 0, 236 as one of our data points, so we'll use that as the y-intercept. Making use of the slope-intercept form of a line, the equation of the line that would model this data would be y equals the slope, which is 15.75 times x, plus the y-intercept, which is given by 236. So that's the equation of the line that we think would do a good job modeling this data. Part B now asks us to find the linear function f that models the data. We've just completed this part. It then goes on to ask us to graph f and the data in the same viewing window and interpret the slope m. Now you may remember the last time we saw our scatter diagram, it looked like this. We had plotted our points on a viewing window where the x values range from 0 to 6 and the y values range from 200 to 350. Now what I've done is I've taken the graphing calculator and I've input these data points. As you can see in the list on the calculator, we've recreated the table from the problem. And now we'll go ahead and take a look at the scatter diagram it makes. And you can see the points on the calculator. We've now been asked to go ahead and input the line equation. So to do that, we'll go to y equals, and we'll type in the equation of the line we found, 15.75x plus 236. And then we'll graph that line through our data points. And you can see that this line models our data points fairly well. In the last part, we're asked to use the function f of x to predict Medicare costs in the year 2006. Now, in order to do this, what you need to realize is the year 2006 corresponds to the x value, x equals 6. So using the graphing calculator again, we'll go ahead and find the function, which we have stored in the y1 variable, and we'll evaluate this function at 6. So finding y1 of 6, that gives us the value 330.5. So what that means is that in the year 2006, the Medicare cost will be $330.5 billion. In this section, you've gotten a chance to take a look at the equations of lines in all their different forms. We've spent a lot of time looking at the point-slope form as well as the slope-intercept form, and we've seen how to use them to model data. You should continue to practice the exercises in your textbook, and I'll see you next time.